Okay, so I have x to the 1/5 and I'm multiplying it by x to the 7/5. What do you do with the exponents? Raise your hand if you know. Danielle, add them. That's nice because they have a common denominator already, huh? Then you have to make one. So what would 1/5 plus 7/5 make? 8/5. Am I done? Any other ideas?
Just making it rational.
Okay, so here are the two questions to ask. Is the exponent positive? Yeah. Is my denominator rationalized? Yeah, because what is it? 1. Okay. So that is a sufficient answer. It's okay because I can write it as a rational exponent because I started out with a rational exponent, and there's nothing else I need to do with that 8/5. No, that was just to show you that the denominator is rationalized because it's 1, so it's rational, right? Getting better at this. Okay, how about B? So Casey, what do you want to do?
Bring it to the fraction plot.
Okay. So I have y to the negative 3/4, so if I make it 1 over y to the 3/4. But is my denominator now rationalized? No. Definitely not. So one thing I could do here is maybe I can rewrite this y to the 3/4. Quentin? Okay. So one thing I could do is I could change this and write it as the 4th root of y cubed. But maybe this may help you more. Remember I told you that I like rational exponents? There's a reason for that. Because what does this exponent need to become? A 1. Right? Or any integer for that matter. But it's easy to make this a 1. What do you have to multiply by to make that a 1? Well, the base is going to have to be y. Remember, what do I do with the exponents when I just multiply powers together? I end up adding them, so the question is, what do I have to add to 3/4 to make 1? 1/4. And if I do that on the bottom, I also need to multiply by y to the 1/4 on the top. And what does that give me for an answer? Well, I have y to the 1/4 at the top, and how about on the bottom? Y. Is my denominator rationalized? Yeah, the exponent is 1. So here we were, Heidi, at y to the 3/4. Yeah, I knew that I needed to add them. That's how I came up with this 1/4. Now, that is the same process as looking at it as a 4th root of y cubed, right? Because what would you need there? You need a 4th root of y, which is really y to the 1/4. So it ends up being the same thing. This is just a faster way of looking at it. in my opinion. Any questions about A or B? Kate? Because I wanted the exponent on y to become a whole number. And so I said, okay, I've got 3/4 right now. What do I have to add to 3/4 to make it the nearest whole number, which happened to be 1? So that's how we came up with 1/4, because I knew when I multiplied the powers, I would be adding the exponents. So that's where the 1/4 came from, because it's what I need to add to 3/4 to make 1. Any other questions? Okay. Onward. 6. 6 has an A and a B too.
Why is it gotta be right back?
I'm with Dominique.
Why does it matter?
Hey, so now I have an 8th root of 81 divided by a 6th root of 3. See, this is what I was talking about. We need to have these rational exponents to do this kind of stuff. Well, what do you look for first? What's your very first step? Look for a way to rewrite my base. How can I rewrite 81? 3 to the 1/2? Okay, so Xander, maybe think about it as what are the numbers that multiply together that are prime to make 81? So maybe 3 to the 4th? Does that have 4 3s, right? Yes, it will become that. Good call. You're ahead of me. 3 to the 4th is what I was looking for. So, yes. Oh!
Just press it back. Just press it back.
Oh, yeah.
Press it back.
Yeah, you're a clever guy. Okay. I'm learning. Okay, here we go. Okay.
You're a clever guy.
Okay. 8th root of, this ends up being,
Oh, it's because your thing is at the top. It's scrolling. You see the thing?
He's just a complete
3 to the 4th. Hopefully you're following along. I don't know what I'm doing. Okay, there we go. That makes sense? Now we can write all these radicals as fractions. So when I do that, this 8th root of 3 to the 4th becomes 3 to the 4th raised to the 1/8. On the bottom, I have 3 raised to the 1/6. And as Xander already reached the conclusion, this 4 times 1/8 makes 4/8, which is really 1/2. So I should have, I guess, just zoomed now. Let you watch it. There you go. So this is 3 to the 1/2. And on the bottom, I still have 3 to the 1/6. Am I finished? No, I have to rationalize that denominator. So, Katie, what am I going to multiply by to rationalize it? You have some idea. You just didn't quite say it correctly. What am I multiplying by? You mean 3 to the 5/6. And I do that to the top and the bottom. So on the bottom then I get 3. On the top, what happens there? 3/6 and 5/6, 8/6. Can I reduce 8/6? 4/3. This 5/6? Well, I have 3 to the 1/6. I needed this number, the exponent, to become a 1. Right now it's a 1/6. So I remember that when I multiply powers, I add the exponents together. So I looked at 1/6 and said, what do I have to add to 1/6 to make 1? The answer is 5/6. Any questions? Waverly.
So, like the original problem, like question, it was started with 81 and 29. Why can't you do that?
Well, because we're not taking a square root. taking the eighth.
Okay.
Eighth root, and I couldn't find 8 threes. I only had 4. Which is why it ended up reducing 8th root of 81 to half the square root of 3. Because even though there weren't 8 threes, there were 4,
Okay.
so I could make it half. Ready for B? Yes. Can I go over this? Like erase it with my white pen?
So you have phase and forward thirds. So she actually wrote that as a radical for you do the fourth, right?
Cube root of 3 to the 4th. Where?
No, down at the answer. So you have to put the power between.
Yes?
So would you be able to?
Continue with that?
Yeah.
So this is like 3 to the 1. And then you could subtract them. So this would be like 3/3 down here. 4/3 minus 3/3. So it'd be the cube root of 3. You could do that. You could. Didn't think about it. That would be more simple. Yeah, I would accept either one of these, but this one's definitely better. So yours, Quentin, you get an ace for that.
But like, what if you were to rewrite it as a radical?
Like cube root of 3?
Yeah.
It would be okay, but generally actually better because we started with radicals, so we should end with radicals. We should probably end it with radicals. Yeah. That's why there's a lot of leniency at this level too. Because they're all synonymous. So we try to come up with ways to have everybody arrive at the same answer looking the same way so that we know whether or not we have the same thing. But sometimes what you end up having to do is take out a calculator, enter it on the calculator, and see if the digits match. Because it's just so hard to tell. That's actually one of the reasons why we have learned to rationalize denominators. We didn't used to rationalize them, and so we couldn't tell across scholars across different countries whether or not we had the same answers to the same questions. Okay, so I'm going to B. All I have to do is erase this part. Okay, I have the 4th root of 9z squared. What do I try to do first? Rewrite the base. 9 is written as 3 squared. So this is, that's a z. Is it a z? Yeah, it's a z. So this becomes 3 squared z squared. Z squared. Which really you could like rewrite this in here, right? So that it would look like 3z all squared. I think that's going to make it easier. Okay, do that. And now what? I need to make this a fraction now. So this 4th root is going to become 1/4. So I have 3z all squared, all raised to the 1/4. So I haven't, yeah, you need to like add different brackets. Separate. So what do you do with the 2, that's an exponent, raised to another exponent? Multiply them together. 2 times a 4th is 2/4, which reduces to 1/2. So I have 3z all to the 1/2. I started out with a radical, so I'm going to end with a radical also. Radical 3z. Questions? Waverly. Oh, in the index here? That's okay. It doesn't hurt to be redundant. Yeah, it doesn't hurt to be redundant. In fact, on the test, a lot of people would forget at the end to write like a little index in there. If it was a cube root or a fourth root. I didn't take you off credit down for that, but that is something you need to be careful about. Okay, example 7, last one. That's an m to the 1/2 minus 1 and an m to the 1/2 plus 1 in the denominator.
Oh, it's a C.
It's a C. So how am I going to deal with this? I need to rationalize this denominator as well. Xander is the only one with an idea. Xander. M to the 1/2? Top and bottom? So if you do that, will you clear all of the fractional exponents in the denominator?
And then plus 1. Oh, wow. I think that's super wrong.
Okay. You're on the right track, but you're just missing one piece of it. Quentin. Subtract 1. Remember, what's that called, this thing? Conjugate. The conjugate.
What did we just do?
We are multiplying by the conjugate. M to the 1/2 minus 1 on the top and on the bottom. Conjugate. Conjugate. It is the magic thing that you multiply by, which is like a fancy one, so you can get rid of all these fractional exponents. Because the key part about the conjugate, Dominique, is that the middle terms, when you distribute this, they add to 0. Because they add to 0, you can get rid of the m to the 1/2 thing, as you'll see here in a minute. Xander. Thank you. Nothing, I was just thanking you. Hey, now let's multiply that out. When you do this, you have to distribute everything. So don't forget the middle terms. Don't funny face either. Just multiply. Just distribute. M to the 1/2 times m to the 1/2. M, because it's m to the 1, right? M to the 1/2 times negative 1. Negative m to the 1/2. And then negative 1 times m to the 1/2 is another negative m to the 1/2. Negative 1 times negative 1? Positive 1. And then same thing on the bottom, but now on the bottom, this is where the magic happens. M to the 1/2 times m to the 1/2 is m. M to the 1/2 times negative 1 is negative m to the 1/2. And then positive 1 times m to the 1/2 is positive m to the 1/2 minus 1. What happens to those middle terms? They are additive inverses of one another. Mr. Mandway? Yes, you're correct. Additive inverses. Pearl, I asked you specifically not to do that. So, then in the numerator, are there any like terms? Any apples?
Yes.
How many m to the 1/2s are there? Negative 2 of them. Does it cancel? There's no factoring in the top that I can do that I can think of that are going to multiply to positive 1 that add to negative 2m to the 1/2, so that's not going to work. We're good. Is our denominator rational? Yeah, we rationalized it. That's good.
So that is
That is the solution. It may seem a bit abstract now, but this is all going to become applicable. I guarantee it. Yes?
What is the end skip